Assalamu alaikum. This is a new Revit Dynamo script to automate Rebar of Beams. This script works for any beam, vertical, horizontal, or inclined, also drawn from left to right or right to left. First, to know each beam's start or end point, which will affect longitudinal rebar extensions, we can use this script to mark each beam's start or end point at any distance of beam's length. Here, start point at 20% of beam's length or end point at 80% of length. Now try a start point mark for this view. Run. Here for this beam, a start point mark at 20% of its length drawn from left to right. Here, this beam drawn from left to right, but this cantilever drawn from right to left. For this plan view, to mark end point, run. Here, end point mark at 80% for all beams. Now back to Rebar script. For Dynamo player interface, we can get beams by three ways. First, a filter selection from model elements and all beams of a selected type, true or false, or get all structural framing elements in active view. For this trial, true for all beams of this type. For these three simple beams, disable this one and try to run the script with its predefined values, then describe it. 3 beams, good performance. Back to our Dynamo player interface here to describe the script. Here for stirrups we can define start spacing for start length, end spacing for end length, and mid or normal spacing for the rest of beams length. For 3 stirrups distribution layouts. First layout, second one, and the third. Or we can choose to have one layout with whatever in start spacing mode. One layout, 150. There is also a consideration of beams that has length less than start and end length. It will automatically be one layout. Like this beam and cantilever with one layout of stirrups. This beam's length 1.5 meters less than start and end length 2 meters. Automatically one layout. Stirrups bar type, shape, start hook type, orientation, an option here to add last stirrup or not. Here no last stirrup. Stirrups display options, set solid, unobscured for a selected view. We can reverse rebar vector if we need it. For bottom rebar, number of bars here could be 0 for no main bottom bars. If we have an extension from a next beam, here bar type, add extension to bar length if positive, or trim if negative. Left and right the bar. Rebar shape, leg length if L or U shape, something like M17A or B. Bottom rebar vertical displacement, if for some reason we wanted to move the bottom rebar up with a specific displacement, would be useful to avoid clashes if we have our extension from a next beam. This feature also moves any depending additional bottom rebar up with the same displacement if there is any. To add first and last bar, here for maximum allowable bars per bottom row, so we can have one or multiple rows for bottom and additional bottom rebar. For additional bottom rebar here, true or false, number of bars if true, bar type, shape, additional bottom rebar length, here is 80% of beam's length because of curtailment if needed, or it could be 1 for the full beam's length. There is an extra feature here for additional bottom rebar vertical displacement, first and last bar. For top rebar, the same options here. There is additional feature here if we have a shape like M17C. For cantilevers, this feature 500 controls this length, this horizontal length. Here E500 horizontal and 450 for this vertical length. This leg length was 450 for this beam, it changed it for another one. Top rebar vertical displacement would be useful to avoid any clashes with next beam's rebar. First and last bar, maximum bars per top row, choose to add top left rebar or not. To check a beam with top left rebar, this one, this beam here has top rebar green and additional top rebar left and right. This is here the start point mark for this beam, drawn from left to right. Additional top left rebar and additional top right rebar. So this additional top left rebar consists of two parts, left and write the support. Our support here is this column R and L. Here is percent of beam's length. Left part of top left rebar here is 30% of this beam's length. Right one also. Our rebar starting from support midpoint. Here for this beam it has top rebar green and additional top rebar. Right part here has length, left one 0. The same here. This is additional top right rebar for this beam. Consists of two parts, left and right. This beam additional top right, left part here, right part is 0. Right left percent of beam's length. This beam here has top rebar, 0 additional top left rebar. It's top right rebar. This beam would have an extension for top rebar here from this beam. It would be additional top right. The start point, left, right. Same options. Also for top right rebar. Shrinkage longitudinal rebar, true to add it or false. Number of bars, bar type, shape, extension, left and right, something like here. This orange. Finally, visibility options for longitudinal rebar, true or false, for a selected view. This is an output for the selected elements to rebar. I have just hidden some options like hook type, orientation and some others to keep some space. Rebar numbers or distribution, not related to any structural analysis or stringing actions, just to show as many cases as we can to check the flexibility of the script. Our last trial here for this beam, if we wanted to add a main top rebar here and additional top right rebar here, making no clashes with any of the next beams. This here is the main top rebar of this beam, but with negative left extension here, and this is the additional top right rebar of this beam for our beam here. First reset. Hide stirrups for this trial. No additional bottom rebar. Vertical displacement. No additional top left rebar. For additional top right rebar. L R L R. Displacement. This is the main top rebar here with left and right extension. Overlap length with a positive vertical displacement to avoid any clashes with this or these parts. And this is the additional top right rebar of this beam with negative vertical displacement to be above the main top rebar, as you see. The additional above the main rebar. There is also another option to control bar bending at a specific distance to avoid clashes using this bar type with a bend here and here, avoiding any clashes, and overlap length here 350 millimeters. For cross sections, we have one here, no clashes, and another, also no clashes. We have here H-beams ID for bar bending schedule. This is our bar bending schedule for each element ID. No bar length exceeds 12 meters, and this is schedule for each bar diameter. That's all for now, and thanks for watching.